This is part B of the Groovy Google Sheet probability distribution graphs, and we're going to be working in the continuous aggregate data section. So we're going to be looking at transaction times in minutes at several branches of Mulock Bank during a 2-hour period. So the X values is time in minutes, and that is continuous data because you can have fractions and decimals of a minute. So once again, your upper bounds and lower bounds are repeating. So you need the square brackets and the curved brackets. And you've been provided with the frequencies. So we're going to be making this probability distribution graph. So in cell B8, you're going to sum up the frequencies. So equals sum and add them up. We need to do this so that we are able to change these into percentages, which is your probabilities. In column C, we're going to calculate the probabilities just the way we did in part A. So in here, we're going to label this as probabilities. And to get the probabilities, it's equal to the frequency divided by the total. And then you need to make that an absolute reference by function F4 or command F4, or for some of you it's even just F4. And then fill that down. And now we're going to create a probability distribution graph using columns A and C. So we don't want the frequency, we just want the time and the probabilities. And remember that that is an area chart. So you're going to highlight column A, lift your finger off the mouse, hit the control button or the command button in a Mac, and then highlight column C, and then insert chart, and we're going to change that to a stepped area chart. And under customize series, we'll just make that look darker. And it says to label it if needed, but you just want to make sure that everything's labeled, the units and the variables in the units, and that labeled probability. So just like that. So if there was a question that said, what is the probability that a customer would have to wait less than 2 minutes? Then that would be these two. So less than 2 minutes here. So that would be the sum of these two. You can look down here. So that would be 0.64. Now in cell E1, so let's move this. In cell E1, we're going to type in time midpoint. And starting in cell E2, we're going to type in the midpoint of each interval. So the midpoint of each interval would be 0.5, 1.5, 2.5, 3.5, all the way to 5.5. And what we're going to end up doing is finding the expected value, which is the average. So because your data is in intervals, you need to use the midpoint as your data. And then in cell A10, type in EX. And then equals, so we're going to be finding the expected value. And expected value is the same as the weighted or the average, the weighted mean or the average. So what we have to do is find the weighted average of this data using these probabilities or the frequencies, whichever way you want to do it. So what you're going to type in is equals average dot weighted, and then you're going to highlight the data, and then comma, and then the probabilities. And what this does is just what the expected value does, is that it takes this piece of data and multiplies it by that probability, plus 1.5 times its probability, plus 2.5 times its probability, plus 3.5 times its probability, plus 4.5 times its probability, plus 5.5 times its probability. And that's just what the expected value is. When you type it in, you get 1.74. So that is, you put minutes here for your units. So the average waiting time is 1.74 minutes. So that's how you can use Google Sheets to calculate the expected value for you. So this here is just what I was saying, that this function here, average weighted, just does this calculation here, which is the formula for expected value. So what does this number mean? It means that the average waiting time is expected to be 1.74 minutes.